Learners, I have a big treat for you today. I have with me Dr. Anand Deshpande, the founder of Persistent Systems and a colleague of mine at IIT Bombay. He's an adjunct professor of practice with the Desai Sethi School of Entrepreneurship. Anand graduated with a computer science degree from an IIT, then went abroad to do a PhD, and has used his computer science learning into practice, set up Persistent Systems, grew it to be a billion-dollar company, and now he's doing new things, he's learning and he's doing. So I can tell you a few things that interest him. One is AI, the other is biology, a third is entrepreneurship. He is very keen on promoting job creation, whether it is at the grassroots level or it is at the entrepreneur or a SME level. So it'll be wonderful to learn AI with Anand, and that's what we're going to do today.
Thanks a lot, Anu. It's always a pleasure to be with you, and looking forward to an exciting conversation.
Thank you. Thank you. So let's start. Our first theme is called Demystifying.
Yes.
Yeah, making AI simpler for all of us. So in this last 2 years or maybe thereabouts, we've been hearing about generative AI or Gen AI. How is it different from what AI used to be earlier?
It's a very good question. So as you know, AI has been around for a very long time. The first time people coined this term was apparently in 1956. And John McCarthy is kind of the one who is attributed to this term. There was a conference and they were talking about certain kinds of algorithms and they made up this term and it stuck. And over the years, people have been working in AI for many years. When I was a PhD student in Indiana, we also had many people working in various aspects of AI. But let me sort of get to the point as to what has changed. So traditionally in the early days, we all felt that symbolic AI or rule-based AI would be the way AI would happen, which means that you define rules that and this was all the intention being that, we want to get the computers to behave intelligently. So that was the main motivation. So how do humans behave intelligently, and then can that be done with computers? So the original thought process was that let's create rules that, like grammar or other places, you define the rules. These were symbolic, and then you would build systems that execute these rules. And as you get further and along, the rules became larger, and all kinds of rules were defined for different scenarios and various kinds of things. So this was the traditional sort of AI where it was very deterministic in the sense that you knew which rules were getting executed and how things were happening. There were languages built around this, and it felt like it had a very good theoretical basis because symbolic languages and symbolic rules and predictive things and all that. So it was Prolog and other languages sort of came out of these rule-based systems. While this was going on in the mid-70s, 80s, mid-80s or so, people started to think a lot about neural networks. So their thought process was the brain is made up of neurons, which are very small units, and these neurons are connected. And the network effect of these neurons in the brain is how we think. So their point was, we don't think in rules. So when we see something, we don't try to say, is it a dog, is it a cat, is it a this? We just kind of make out and we are able to figure out what it is. So there is this whole concept that it's based on a neural network. So a lot of people started to work on this another form of AI, which has been called the neural network, or that's where it started. Now, as you would have seen, AI has gone through many patches. So they call the hibernation of AI. And I think what is interesting to note in this specific context is that we refer to Geoffrey Hinton as the father of AI. And if you see some of his work that he did, a lot of his work happened in the late 70s and early 80s, deep learning, neural networks, back propagation, and several of the algorithms. But then, when people were building these neural networks in the 80s or even in the early 90s, the compute facilities, the amount of memory, all of that was very limited. So people built networks which were very small, meaning hundreds of nodes and thousands of nodes and all that. And at that point, it gave very limited results. Nobody felt that this was going anywhere, and people had kind of given up on neural networks as a way to make this happen. But I must give it to Geoffrey Hinton's persistence that he kept on with it. And for almost 20 years, nothing much happened in the field. So 2006, 2007, Fei-Fei Li, who is again considered the godmother of AI, she was at Stanford. She built an image data set. So she created catalogs of images, cats, dogs, things like that. And then there were all these SIG-KDD, which is the Special Interest Group for Knowledge and Data Discovery. SIG-KDD is another ACM SIG. They started to run competitions to say that can you build systems that would be able to identify objects accurately. So that's how people came back with, in the 2007, 8, 9, 10, 12. By the time 2013 and 14 came by, it was very clear that the neural network based AI algorithms were winning these competitions hands down. So people then again felt like this was going to happen, and then few other algorithms from Google that added on to it. Effectively, people started to invest a lot of money in trying to build very, very large neural networks. So initially, when we were talking about as in the 80s, it would have been thousands of nodes. Then they went into billions of nodes and very large number of very, very large networks, and that's where the GPUs and all the other things started to come in. And that's sort of when, when 2023, 24, when ChatGPT moment happened, as they say, they released a very large model, billions of parameters, and all of a sudden people saw that it could do some amazing things. So in a sense, this was sort of the new AI, as we call it. And the difference is that in a traditional old AI, as you saw the symbolic AI, you had rules that you had to define upfront. Here you are not defining the rule, you are letting this network learn on the basis of data that it is reading from various sources, and it's training it in the context of that network. And when the network is trained, then you can use inference to check what's happening. So this is really the new model, and it generates answers. So that is why it's called the generative AI. So the previous one was more symbolic, more predictive. This is more more deterministic. This is more probabilistic and generative AI. So this is sort of what is different, and ChatGPT was the first one, and then of course we have many other such things in it.
So I think it's a great history tracking that you have done for us. We hear the word model used often in the context of generative AI. What exactly is a model? And this time I'm going to ask you to explain this, imagining that the people who are listening are not techies.
This is very important. Model is very important to think about, because what has happened is that when we look at Google and other things, we look at search. What search does is you do a lookup and you see a result which is already present and you give that answer.
It's already present.
So what happens in a model is that you don't, so let me take two examples and then we'll go through it. So the oldest one, simpler one would be that you take something like, Galileo went up to the Leaning Tower of Pisa and started dropping balls, and he started to collect observations, and he looked at that data and he created the equation for, gravity and all of that stuff. So this was before Newton in a sense. So this was a little different. He didn't really use, so he created an equation on the basis of observations, basically curve fitting and whatever he did. And then once you had that equation, right, now even if I went to a height that was way beyond the Leaning Tower or any other number, I could automatically predict the answer irrespective of where it was going, because I had a formula, so to say. That formula was like a model, meaning once I give it some input, it gives me some output. Now this is very simplistic, very crude, it's very deterministic, it's a fixed equation and all that stuff. But imagine how a doctor operates. So typically when you go to a doctor looks at your symptoms and gives a diagnosis, and then potentially gives a treatment and a protocol. But when he looks at the symptoms, when the doctor is looking at these symptoms, it is not that they have seen all these symptoms. Of course, when they are trained on, headache, this, so they know hundreds of symptoms on which they know. But a patient who comes in with very unique symptoms that they have never seen before, they are still able to diagnose that, okay, fine, I think this is mostly like this and somewhat like that and something like that. So they are not always giving a precise lookup answer. They don't tell you that, oh, sorry, I don't have it is not in my table, so I can't give you the answer. ऐसा नहीं करते हैं. They always they sort of give and very good results. So नहीं almost ऐसा है 30% probability ऐसा है 50% ये probability हो सकता है, ये भी हो सकता है, वो भी हो सकता है. तो let's figure out क्या हो सकता है, right? So they diagnose one by one. तो ये same thing happens with neural networks, because neural networks are probabilistic. So you are able to see कि अच्छा I think कि this is probability wise 0.8, this is 0.7, so ये भी हो सकता है, वो भी हो सकता है, but मेरे को ऐसा लग रहा है कि ये ज़्यादा होगा. So ऐसा मिक्स एंड मैच करके मॉडल होता है. सो मॉडल में आंसर्स आर नॉट एक्यूरेट एंड एग्जैक्ट, दे आर नॉट लाइक अ लुकअप. आई एम नॉट लुकिंग एट अ रिजल्ट एंड गिविंग यू बैक. आई हैव kind of learned a lot of things and built a model, meaning these weighted graph, and it generates probabilistically the next token in some sense. And in a way, this is also important to note, since I mentioned this. One other thing to think about this next token generation, which is what generative AI is all about, and the fact that it generates. The best example is कि हम लोग मोबाइल फ़ोन में जब हम लोग SMS टाइप करते हैं या हाँ हम लोग जब प्रेडिक्टिव मोड में हम लोग मतलब अपने टाइप करते हैं तो ऑटोमेटिकली नेक्स्ट वर्ड बताता है. तो वो नेक्स्ट वर्ड कैसे बताता है कि उसका प्रोबेबिलिटी है कि अगर आपने इतने बार यही चीज़ टाइप किया है तो ऑटोमेटिकली उसको लगता है कि मोस्ट लाइकली ये होगा, मोस्ट लाइकली ये होगा. एक एक वर्ड टाइम में प्रेडिक्ट करता है. अच्छा ये दो है बड़ा मॉन्स्टर है, तो सिर्फ नॉट जस्ट वन वर्ड, इट कैन प्रेडिक्ट मैनी वर्ड्स टुगेदर, एंड दैट्स हाउ इट्स जनरेटिंग इट. एंड वन अदर थिंग इज यू विल नोटिस इज दैट if you kind of keep asking it to the same question with different times, different people, different contexts, it may not give you the same answer every time, right? It will give you different answers. That is because it's using a probabilistic algorithm. At every point it's deciding with certain probability कि next word क्या होना चाहिए, next word क्या होना चाहिए. ऐसा करके नया पोएम बनता है. तो आप बोलोगे नहीं मेरे को 5 पोएम चाहिए, तो अलग अलग प्रोबेबिलिटी, फर्स्ट वर्ड का ये था, सेकंड इस बार दूसरा यूज़ कर दिया, इसका तीसरा यूज़ कर दिया, ऐसा करके नया चीज़ जनरेट होगा. तो ये जो प्रॉपर्टी है जिसमें एक्यूरेट आंसर्स जो है मतलब लुकअप नहीं है बट मॉडल पे डिपेंडेंट है और थोड़ा जनरेट करने की उसमें कैपेबिलिटी है, इससे रियलिटी की यू गेट वेरी डिफरेंट काइंड्स ऑफ रिजल्ट्स एवरी टाइम यू रन इट. सो दिस ऑफन यू नो पीपल लुक एट दिस एज हेलुसिनेशन कि यार ये मॉडल हेलुसिनेट करता है, बट ये तो डिज़ाइन है इसका. हाँ डिज़ाइन किया है ना इस तरह से कि प्रोबेबिलिस्टिक आएगा. अच्छा एक उसको मैं बताना चाहता हूँ आपको कि ये हमारे नेचर में भी हमारा जो पूरा सिस्टम बना हुआ है वो उसमें भी ये थोड़ा बहुत प्रोबेबिलिस्टिक डाला हुआ है. लाइक फॉर एग्जांपल आप देखोगे तो हम लोग जेनेटिक्स हैं, हेरिडिटरी की बात करते हैं जीनोमिक्स में कि हमारा जीन था उसका नेक्स्ट जनरेशन में थोड़ा हुआ ये हुआ, बट एक दो चीज़ उसमें एक है क्रॉसओवर और म्यूटेशन. ये दो चीज़ें हैं. इसमें क्या है कि हमारा मोस्टली सेम चीज़ आएगा, मतलब hereditary it keeps most of the gene is the same but some variations happen. फिर हम लोगों को डार्विन जैसा मालूम है कि अगर वो स्ट्रॉन्ग है नया म्यूटेशन तो वो सर्वाइव करेगा, अगर नहीं है तो वो निकल जाएगा. तो इस तरह से जो है हमारा जो नेचर में भी इस तरह का है कि अगर हम लोग हमेशा सेम रखेंगे तो वो स्पीशी तो वैसा ही रहेगा, कभी इवॉल्व नहीं होगा. बट ये इसके कारण क्या है कि हमारी नई स्पीशी तैयार होती है और फिर when you get good quality results you get better results, right? So इस तरह से यहाँ भी इस तरह का मॉडल है कि हाँ हमेशा हमको एक ही रिजल्ट नहीं डालना है, हमको थोड़ा वेरिएबिलिटी डालना है. और वो आप सेट भी कर सकते हो कितना चाहिए. अगर आप उसको बोलोगे थोड़ा प्रोबेबिलिटी में थोड़ा ऑप्शन दे दे कि यू कैन यूज़ एनीथिंग बिटवीन 0.7 and 0.9 और व्हाटएवर, देन यू विल गेट फार मोर इंटरेस्टिंग न्यू आंसर्स, क्रिएटिव आंसर्स. इफ़ यू बी वेरी प्रिसाइज हमेशा वही चीज़ तो तुम्हारा आपको फिर अलग आंसर आएगा. तो ये जो है ना पूरा मॉडल देख के नॉट गिव अ प्रिसाइज आंसर बट ऐसे आप पूछो फिर मॉडल थोड़ा सोच के कुछ बताएगा. दैट इज़ व्हाट मेक्स एआई वेरी इंटरेस्टिंग एंड ऑल्सो काइंड ऑफ पावरफुल इन अ वे, क्योंकि नई चीज़ भी डिस्कवर हो जाती हैं.
So just explain to us, it's called a large language model, LLM.
Correct.
So and one more, I'll give you two questions at the same time. Help us understand LLM, and if you can take an example and explain the context, which is if I'm asking the question in a different context, just if you can take an example.
So पहले let's talk on LLM.
LLM.
हाँ. So it's large language model. It is exactly what it says. इसका मतलब यह है कि हम लोग जब मॉडल बना रहे हैं तो हम लोग ने लैंग्वेज के ऊपर मॉडल बनाया है. इसका मतलब क्या किया हमने, हमारा जो लैंग्वेज टेक्स्ट है मतलब अभी क्यों हुआ ये भी देख लीजिए. दिस इज द ईजीएस्ट थिंग टू डू because language is available, text is available. I can train with large amounts of books, Wikipedia, all the web pages, all of them are text and language. सो इंस्टेड ऑफ डूइंग द रूल्स कि इसका ग्रामर ऐसा है, ये है, उसका पूरा थियोरी टैक्सोनॉमी, ऐसा कुछ नहीं किया, बोला चलो सीख लो। तो पूरा का पूरा जितना भी वेब क्रॉल है, एंड दैट्स वेरी इंटरेस्टिंग टू लुक एट, ये जो क्रॉल जो हम लोग बोलते हैं जिसमें मिलियंस ऑफ पेजेस ऑफ वेब पेजेस, विकीपीडिया पेजेस, बुक्स, जर्नल्स, आर्टिकल्स, ये जो भी ओपन सोर्स में है अवेलेबल है, वो ख़रीदा जा सकता है। अगर आप अमेज़ॉन की एक साइट पे जाओगे और बोलोगे हमको यूनिवर्सल वेब क्रॉल चाहिए, तो आपको मिल जाएगा। तो वेब क्रॉल जो है, वो जो क्रॉलर इंजन्स हैं वो हमेशा क्रॉल करते रहते हैं और डेटा कलेक्ट करते रहते हैं, वो सब डेटा लेके वो बेचते हैं एक्चुअली। और जिसको भी ये ट्रेनिंग करना है वो क्रॉल ख़रीदता है, वहाँ से अपना पढ़ा देता है, लैंग्वेज को लेके पढ़ा दिया। सो एक तो लैंग्वेज से हुआ, इसलिए लैंग्वेज मॉडल है, और लार्ज है क्योंकि बहुत ही ज़्यादा लार्ज है, तो 100 बिलियन पैरामीटर्स, इस तरह का मतलब बहुत ही बड़ा है। हाँ, थोड़ा पैरामीटर्स इज़ कॉम्बिनेशन ऑफ फ्यू थिंग्स। देयर आर बेसिकली ये सब न्यूरल नेटवर्क जो हम बनाते हैं, ये बेसिकली एक ग्राफ बना रहे हैं। ये ग्राफ है जिसमें नोड्स हैं और एजेस हैं, एजेस में भी वेट्स हैं, सो वेटेड ग्राफ है। और डायरेक्टेड ग्राफ है, मतलब एक साइड से शुरू होगा आगे जाएगा, तो उसका एंड में आता है कि आउटकम बहुत सारे हो सकते हैं, और इस तरह का ग्राफ बनता है। तो कितने पैरामीटर्स हैं, सॉर्ट ऑफ अ फंक्शन ऑफ द नोड्स एंड द एजेस, एंड कितने जगह पे हम लोग ने ट्वीक कर सकते हैं। मतलब हर नोड में एक वैल्यू आ जाती है वेक्टर, और हर एज पे एक वेक्टर आ जाती है, तो कुछ पे नहीं भी आ सकती, बट मोर और लेस वो होगा। तो हम लोग कितने पैरामीटर्स इस तरह के इसमें आएंगे, उस पर हमारा ग्राफ बनता है। और इस तरह के पैरामीटर्स करीब 50, पहले तो बिलियंस में थे, पर अभी 700 बिलियन 800 बिलियन टाइप में काफ़ी बड़े बड़े ग्राफ बन रहे हैं। तो इसीलिए इनको ट्रेन करने के लिए भी अपने हमें जो है ना वो सीरियस जीपीयूज, सीरियस सीपीयूज, बहुत सारा खर्चा, इलेक्ट्रिसिटी, ये सब जो है इसी के कारण है। तो ये आपका पहला प्रश्न था कि एलएलएम क्या था। दूसरा आपने पूछा कि कॉन्टेक्स्ट क्या चीज़ है। तो देखिए, हम व्हेन वी आर डूइंग एसएमएस, राइट, तो और यहाँ आप व्हाट्सएप में मैसेज दे रहे हो, तो कॉन्टेक्स्ट में वो एक वर्ड एट ए टाइम बताता है। हाँ, अगर हाँ, इट प्रॉम्प्ट्स वन। इसमें अगर हमको चाहिए कि आपको पूरा मेमोरी में रखना चाहिए कि सिर्फ एक नहीं, मेरी पूरी पोएम बनानी है, 40 वर्ड, 100 वर्ड, 400 शब्द, 2000 जो भी है वो आने चाहिए, तो नाउ इट शुड नो कि पहले का वर्ड, नेक्स्ट का वर्ड, अभी नेक्स्ट, सो इट शुड हैव सम कॉन्टेक्स्ट, इट शुड मेक सेंस ओवर ए लॉन्ग ड्यूरेशन विंडो, राइट। सो दैट विंडो ऑफ हाउ लॉन्ग यू कैन थिंक प्रीवियस, मतलब how much data can it understand and how much data will it come broadly, okay, I'm not being very precise, is typically referred to as a context window. तो इसका context window मतलब कितना बड़ा हो सकता है। हाँ, इसके अंदर एक बताना चाह रहा हूँ कि एक इसके अंदर एक गूगल ने एक पेपर लिखा था ट्रांसफॉर्मर एंड अटेंशन के बारे में, जो इसके लिए बड़ा इम्पोर्टेंट कहला जाता है। तो ये जो था, इनका कहना था कि अगर आप पहले क्या था कि एक एक करके वर्ड देख रहे हैं, हम लोग एक वर्ड एट ए टाइम दे रहे हैं, तो उससे जो है ये थोड़ा क्लैरिटी नहीं होता है। और दूसरा क्या है कि verbs and nouns in the context of where they show up can have a meaning. So if I have a long sentence, I don't always know what is the context of that particular word, because it could be he's sitting on the chair, he is sitting next to the chair, under the chair, ये सब भी हो सकता है। So अगर ये सब complexity, अगर हमारा context window बहुत छोटा है तो हमको ये पता ही नहीं लगेगा कि क्या हुआ। तो इन्होंने सब बताया कि ये अटेंशन और ट्रांसफॉर्मर आर्किटेक्चर ये सब दिखाया कि कैसे आप बड़ा बना सकते हो, कैसे डिकोडर इनकोडर बनाते हो। ये सब कॉम्प्लेक्सिटी मैं अभी बताना नहीं चाहता हूँ, बट अगर हम लोग एआई का एक जो बताते हैं कि जो 10 एल्गोरिथम आप कहें कि जिसके कारण देयर बीन अ स्टेप फंक्शन इम्प्रूवमेंट इन द वे दिस होल थिंग वाज इंटरप्रेटेड, the attention architecture, the transformer architecture is considered one of the important papers that Google invented and then opened it up. I mean, they didn't realize how powerful it was, and they kind of published it, and there's an Indian author and all that.
The Transformers paper, since you are on languages right now, does the computer understand what we are typing? What is the
ये थोड़ा आपने बहुत फिलोसॉफिकल प्रश्न पूछ लिया। अंडरस्टैंड का क्या मतलब है, वहाँ से शुरू होता है। But there is, by and large, most people believe that the computer doesn't necessarily understand, but it knows enough about what needs to be done. So it feels like it understands, but it doesn't have the feelings or any of those things. And the understanding का concept क्या है वो थोड़ा open-ended है, but by and large people believe that these are in a way stochastic parrots, और इसमें बहुत सारा डिबेट है, कुछ लोग बोलते हैं कि नहीं बहुत ही जानता है नहीं जानता है, बट या
if it is so language dependent, how will it work on Indian languages?
हाँ.
Because all of our conversations have been about sitting on the chair, under the chair, over the chair.
हाँ.
Yeah. So how will, so I know that there is some work happening in India.
हाँ, आपके IIT में भी हो रहा है.
It's good to talk about it now.
हाँ, तो ऐसा है इसके अंदर दो, मतलब एक और थोड़ा नेक्स्ट लेवल में हम लोग इसके बारे में बात करते हैं. सो वन ऑफ द इम्पॉर्टेंट थिंग्स टू नोट इज़ कि जब हमारे पास पूरा लैंग्वेज आ जाता है, मतलब टेक्स्ट है, तो क्या है कि यू हैव टू डिसाइड कि व्हाट इज़ द यूनिट एट विच यू आर ऑपरेटिंग. So that is referred to as a token.
Oh, token, yeah.
So this token is important because आपको when you read something or when you start using it बोलेगा कितना token consume हुआ, कितना token हुआ. So इसका जो unit है वो token है. अच्छा, token कहाँ से आता है कि they take a word and basically there is a tokenizer that if it's a long word it will take stems of the word or parts of the word or whatever else, and it builds a token. The token basically converts it into a large vector of numbers. So that's the token, and then that token is used to train, and the unit, it's the unit of how things happen. So in a language model, the tokens are language entities, right? Syllable ये होगा, so verb होगा, जो भी होगा, letter, पूरा letter नहीं होगा, कुछ collection of letters है, 3-4 letters मिला के होगा, या मतलब कोई बड़ा word है तो उसके 2 parts हो सकते हैं. क्योंकि इसका कहना यह है कि अगर मुझे फिर ये वेक्टर स्पेस बनता है, जो पूरा जो नेटवर्क है, इसके अंदर आइडिया ये है कि अगर 2-3 रिलेटेड चीज़ हैं तो वो आसपास रहें, तो इफ़ आई एम इंटरप्रेटिंग, इफ़ आई कांट सी दिस वन देन आई सी समथिंग नेबरहुड, आई मे बी एबल टू स्टिल मेक एन इंटरप्रिटेशन आउट ऑफ इट, राइट? सो नाउ ऑन अ वेरी क्रूड लेवल, अगर आप हिंदी लें या कुछ और लैंग्वेज लें, तो या समथिंग सिमिलर कैन बी डन. यू कैन यूज़ अ सिमिलर टोकनाइजर. इट विल टेक द टेक्स्ट स्ट्रिंग्स दैट यू हैव, not necessarily interpreted, but because it's seeing lots of data, it can make good sense out of Hindi, English, whatever, Marathi. And because the volume of data that it's using is so large that it has this ability to kind of be mostly correct. But of course, it's not accurate enough. So अभी आप हमारे मतलब अभी के कॉलीग, जो हमारे कॉलीग हैं यहाँ पे, गणेश एंड बाकी लोग, वो जो हाँ भारत जैन में काम कर रहे हैं, वो लोग, उनका कहना है कि हमारा जो ग्रामर है, हम लोग जिस तरह से संस्कृत, हिंदी, मराठी जो भी लिखते हैं, उसका कुछ मतलब उसके जो टोकन हैं, अगर हम लोग इंग्लिश टोकन की जगह पे अगर हम लोग हमारे टोकनाइजर यूज़ करें और उसको अलग तरह से टोकन करें, तो कुछ कम टोकन्स में भी हमारा काम हो सकता है, तो एफिशिएंसी बढ़ सकती है, लैंग्वेज ट्रांसलेशन बेटर हो सकता है. तो इस तरह से हमारे यहाँ काम हो रहा है, जिसमें हम लोग जो टोकनाइज़र है वो इसको हम लोग थोड़ा अलग तरीके से देख के कैसा करना चाह रहे हैं, देख रहे हैं. ये टोकनाइज़र बड़ा इंपॉर्टेंट चीज़ है, क्योंकि अगर हम कोई और मतलब ये जो अभी हम लोग बाद में बात कर सकते हैं इसके बारे में, बट ये लैंग्वेज मॉडल का जो लैंग्वेज का कारण है, ये टोकन के कारण है. अगर लैंग्वेज के टोकन्स यूज़ करके तो लैंग्वेज मॉडल बनेगा. लोग आगे बात करें कि वर्ड मॉडल्स है, इस तरह के नए मॉडल्स की बात करें जहाँ टोकन्स आर नॉट लैंग्वेज टोकन्स बट कैन बी समथिंग एल्स. लाइक फॉर एग्जांपल बायोलॉजी वाले बोल रहे हैं कि अगर हम लोग DNA या सेल्स को लेके सेल को टोकन बनाया, तो सेल का रिलेशनशिप में अलग टोकन बनाया, तो अगर हम लोग टोकनाइज़र में थोड़ा अलग सोचें तो कुछ और भी बन सकता है. तो ये अभी और काफ़ी रिसर्च होने लायक है यहाँ पे, तो उसके बारे में बाद में बात कर सकते हैं. बट टोकनाइज़र जो है वो बहुत इम्पॉर्टेंट है, और हाँ, किसी लैंग्वेज को हम किस तरह से टोकन बनाते हैं और ये टोकन्स किस तरह से सेट करते हैं, जैसे रिलेटेड टोकन्स आसपास आएँ, तो दैट इज़ एन इम्पॉर्टेंट थिंग. इसका एक और वेरिएशन है जो काफ़ी आप मतलब यू सी दैट इफ यू स्टार्ट टॉपिंग इन इंग्लिश, इट विल टेल यू मराठी, इट कैन गिव यू हिंदी, इट कैन गिव यू इंग्लिश, बिकॉज द टोकनाइजर इज एक्चुअली पुशिंग these into related sort of close by areas, and the images are also kind of overlaid on that. So this is very important because this is what gives it the multimodality of AI, as we say. A lot of that has to come from how tokenizers are made and what kind of algorithms you use for deciding what the small entities are and how you can combine them across various things. So बहुत important है.
In this section, I'll just ask you about hallucination. You already referred to it. And then we'll come to multimodality and how are images being created and so on. So just for our students, explain hallucination and that what you were saying, which is You can, I didn't know that individuals can set a probabilistic.
हाँ, कुछ मॉडल्स में कर सकते हैं. पहले बहुत इजी था, अभी बहुत सारे पैरामीटर्स लोगों ने मतलब आज के तारीख में हटा दिया क्योंकि मोस्ट पीपल डोंट गेट इट एंड यू आर नॉट एबल टू डू इट. हेलुसिनेशन का ऐसा फंडा है कि देखिए ये जनरेटिव एआई है, नई चीज़ें बना रहा है, पोएम्स भी बना रहा है, स्टोरी भी बना रहा है. जो स्टोरी बना रहा है तो ये स्टोरी इज़ नॉट रिटन समवेयर, नई स्टोरी बन रही है, इट्स जनरेटेड, कम्प्लीटली फिक्शनल, कम्प्लीटली फिक्टिशियस. तो इसका मॉडल लेके हम कुछ भी जनरेट कर सकते हैं. उसको कुछ मालूम नहीं है, उसको तो पैटर्न्स मालूम है, तो पैटर्न चिपकाता है. तो इससे क्या हुआ है कि बहुत सारी केसेस हैं जिसमें आप किसी को पूछोगे कि मेडिकल में आप पूछोगे कि मेरे को कोई रेफरेंस दो, तो कुछ रेफरेंस बना दिया, कुछ नया ही चीज़ बना दिया, जो था नहीं वो भी बना लिया. फिर किसी को आप पूछोगे कि इन्होंने क्या काम किया है, इसके बारे में क्या है, तो आपको रेफरेंसेस देंगे. बट रेफरेंसेस सही हैं इसका कोई गारंटी नहीं है, क्योंकि वो तो मॉडल जवाब दे रहा है, लुकअप तो जवाब नहीं दे रहा है. अगर आप गूगल में जाके सर्च करेंगे तो कुछ और मिल सकता है. तो अभी बीच में एक केस निकला था जो सुप्रीम कोर्ट में था या किसी कोर्ट में था, जहाँ पे लॉयर ने अपना जनरेट कर लिया, केस की स्टोरीज भी बना दी, रेफरेंसेस भी दिए, बट वो रेफरेंसेस सच नहीं थे क्योंकि वो मॉडल ने जनरेट कर दिए, मॉडल तो फेक रहा था. हाँ, कुछ और बना दिया. तो ऐसा है कि ये जो हेलुसिनेशन है ये बाय डिज़ाइन है, जो मैं आपको बताया कि मतलब बनाना है, इसी तरह से मॉडल बनाए, इसीलिए वो क्रिएटिव है. क्रिएटिव है तो नई चीज़ें निकाल रहा है. अगर वो क्रिएटिव है और नई चीज़ें निकाल रहा है तो कुछ तो नई चीज़ें हैं जो पहले कभी देखी भी नहीं है, कभी है नहीं. तो अगर आप अपना काम कर रहे हो तो ये आपकी जिम्मेदारी है कि अगर इसने कुछ बनाया है तो आपको वेरीफाई करने की ज़रूरत है कि अगर उसने रेफरेंस मांगो, उनको रेफरेंस मांगो, रेफरेंस देगा, फिर कुछ और मांगो, फिर वो रेफरेंस मिलेगा, तो आपको लुकअप या ऐसा कुछ करके वेरीफाई करना चाहिए कि वो रेफरेंस सही है कि नहीं, क्योंकि झूठ बोलता है यार. और दूसरा एक और चीज़ आपने देखा होगा, वेल हाँ, मतलब इन अ वे कुछ भी बोल सकता है. हाँ. दूसरा एक और चीज़ है जो काइंड ऑफ इम्पॉर्टेंट है इसमें सोचने के लिए, कभी भी आप उसको कोई भी प्रश्न पूछोगे जवाब देगा, बहुत कॉन्फिडेंटली जवाब देगा. और आप जैसा क्वेश्चन पूछोगे उतना ही पोलाइटली और आपके बात में हाँ मिलाते हुए जवाब देगा. तो ये थोड़ा मतलब बच के रहने के लायक है, क्योंकि अगर आप उसको किस तरह से आप पूछोगे उस तरह से आपको जवाब मिलेगा. और कभी मना तो करेगा ही नहीं, उसको मालूम भी नहीं होगा तो भी ऐसा नहीं बोलेगा कि मुझे नहीं मालूम है. ये इसका ट्रेनिंग है, तो थोड़ा बच के रहना ज़रूरी है.
We've been talking to Anand about artificial intelligence, and we're going to shift gears. So far we've been talking of AI, and it has been language and text based. You used the term multimodal, but is multimodal also to do with AI being video and images and so on?
Yes. Yeah, so what happens is with AI, right, and the way we are training one model, which is very huge with all kinds of things, people found that the same model can interpret different kinds of things. So while you do the tokenizing, when you do tokenizing for languages, people have found that I can do the same thing with images or video to some extent, definitely audio and all of that. And people have kind of added audio, video and all of that all back into the same model. So, but when you are doing that, one of the things that people, when trainers, when they are training them, they kind of make sure that the dogs, that the image of the dog, how you call the dog or kutta or whatever else, and the fact that DOG, jo bhi likha hai, wo sab, they come together. They also get some hierarchy, taxonomy gets created about how things are related when you're looking at animals or various other things. And this ability of AI to interconnect unrelated things potentially, sometimes of course related ones, but because of the fact that it is connected with in a certain way, and sometimes you don't always know how it is connected, it has this uncanny ability to interoperate all kinds of unrelated things in it. So if I wanted to have, let's say, my so I have financial data about what's happening in the stock market or whatever, and I wanted to apply physics principles to stock market data. Potentially that is possible in this kind of a world because you have the ability to make that happen. And when you look at images also, so what happens is that it looks at images in a very different way. It doesn't look at it like pixels and points and all. It sort of understands objects and it is able to cluster them in certain kinds of things. And there are techniques that are fairly well known in vision and other things. So if you're looking at, for example, you're driving, you want to see objects, how do you see that? How do the eyes see it and how do humans see it? So all of that has been sort of incorporated into it. So very sophisticated AI has happened on video and image over the years. and that has helped you to, so if you, for example, when you look at asking say a Nano Banana or anyone else like that to generate an image, it's not picking an image that already exists. It creates a new image, and it is able to bring components from different places and put it together as if it's one unified image. So once in a while it makes a mistake, so you'll find someone with three legs, or four fingers or seven fingers or whatever else. So that happens because it's generating that, and sometimes if you see the image, the text that gets generated, spellings are not correct and things like that. So this is all part of how it generates, but its ability to interconnect different kinds of things, because the space of how it defines this multidimensional vector space and algebra and all of that stuff, that is sort of why it makes it possible to do this multimodality. While at this, let me also explain one thing. So at the very nuts and bolts of this, each of these tokens basically converts into a vector. Vector is like an algebra, linear algebra vector, and you're building this huge graph. Graphs can be represented with nodes and edges. Each edge has weights in it, and all of these are again converted into vectors and matrices. So effectively you are processing very large matrices as part of this algorithm of training and everything else. And so the interesting story here is how GPUs became relevant. So GPUs, which NVIDIA makes, in the early 90s, they started to, people were using gaming boxes and computer and PCs for games, and they realized that the CPU gets choked and it's not very efficient when it comes to raster, getting the movement of the video and the games and all moving very fast. So NVIDIA created a GPU, which is a graphics processing unit. So it's a card with a bunch of cards with some chips on it, which are meant for this multiplication and other vector things, and basically it can do algebra of vectors very easily. So lots of dots with weights on them, and you can compute them very effectively. So when people started to do all of this deep learning and all that, they found that, oh, GPU already does this kind of vector stuff very well. So let's start using GPUs for training. And GPU, while it started in graphics world, has all of a sudden become the hot
NVIDIA
property.
NVIDIA
Stock went off the roof. So it's a 30-40-year-old company, but 30-year-old company, I would say 30-35-year-old. It was there in the early 90s. But for many years, it was a GPU company. So they did well, but they were not the star of the world. But all of a sudden, when AI started to use GPUs, and GPUs found that this was the right thing to do, and they made their GPUs programmable. So they use something called CUDA as their language that they use for programming GPUs, and that's what is used by these kinds of algorithms. A lot of deep computer science, algorithmic work, algebra, maths, all sort of rolled into this whole thing of training. And while we talk about multimodality, I think I want to mention two parts of it. So pehle we train the model. So you read documents and all that, this training. This training is a kind of a one-time process. It's a batch activity. It takes a long time to train. So you don't train all the time. You can do a little bit of incremental training, but by and large training happens once. Once you have trained the model, then you ask questions against the model. So when you ask questions against that model, that process is called inferencing. So you have training and inferencing. So of course the cost of training is very high, but it is not done every time. It's done frequently, but regularly and periodically, let me say that. But when you do inferencing, every time you ask a question, you are doing an inference. So every time you do a question, you go through the network and it gives you a result. It's not training the result. So no new knowledge is created at the time of training.
The query itself is not creating new knowledge.
Well,
by and large.
By and large. So yes, it does realize, and then there's some, so okay, let me sort of get you to this thing. So what happens is that the network kind of generates lots of things. But Abhi, when you want to make it available for people and all that, you have to make sure that it doesn't give you bad things, or it doesn't go too out of the whack, or sometimes context is something that is not quite obvious. So there is usually a fairly large post-processing layer that happens after the neural network has done its job. In the post-processing, they're very broad. There's a lot of things that happen, but very broadly, one important thing that they do is they customize it to local things and ensure that bad things are not coming, and to some extent, to the extent that they can, they will say that these answers don't give them, or ऐसा आएगा तो change कर दो या कुछ भी कर दो. So इस तरह का जो है, that happens post processing of these things, right? So that's another kind of thing that happens. So there's a lot of work that is done not just in training the model, but after you have trained it, post-processing the model so that it can work in the context and give more meaningful answers. And if you're talking biology, then this and that. And so there's a lot of work that happens in just producing these models and giving results to the market.
And all the time that you have been saying training the model, is that what is a foundational model?
हाँ. So foundational model का फंडा ऐसा है कि these very large models which are, so on one side if you look at say Anthropic, which is Claude, and OpenAI with ChatGPT, and Gemini with Google, these are the biggest ones that are available, and everybody seems to be using these three. And then there's Grok from Elon Musk and a bunch of others. And there are others also. Lots of people have models that are there. But these are large, very large models. So their goal is to learn everything that can be learned in the world in some sense. So that's like completely maximalistic opinion. And their goal is AGI, which is to get to general intelligence. So kuch bhi pucho, kahin se bhi pucho, I should know. And then they are getting to 700 billion parameters. So these are typically referred to as foundational model. So you have not trained them for a specific use case. You have trained them for general use case. Any question you want to have, you should be able to answer that. So that's sort of the trend why they are called foundational models. And yeah, they are also language models. But one interesting thing to note is, as I said, you have these vector which has numbers, and you get this huge 700 billion parameter and all that. Now you can save that numbers into a file, let's say, and read it again somewhere else, right? So now let me transform that to smaller models. So what people have done is that they have done open source models. So let's go one step at a time. Sure. So if I want to build a simpler model, let's say I want to only learn English, I don't want to read anything that is in Norwegian, Danish, ये सब नहीं चाहिए, मुझे सिर्फ English चाहिए, और मुझे सिर्फ विकीपीडिया ही चाहिए, बाकी कुछ नहीं चाहिए.
So my input is only.
मैं रिस्ट्रिक्ट कर दिया, मैंने छोटा मॉडल बना लिया, फिर छोटा मॉडल लेके मैंने सेव कर लिया मतलब उसका जो पैरामीटर्स था वो सब अवेलेबल है, निकाल लिया, रख लिया, अलग रख लिया. फिर मैंने किसी और को दे दिया वो पैरामीटर्स, और वो पैरामीटर्स मैंने फिर रीड कर लिया, तो मेरा स्टार्टिंग पॉइंट वहाँ आ गया. उसके बाद मैंने उसको समझ लो फिजिक्स पढ़ा दिया या so the ability to save, so models are large number of parameters. All these parameters are, let's say simplistically, huge matrix, lots of parameters, lots of numbers, and they are like a state of trained matrix.
Oh, adding it up.
Now that state of trained matrix I can save and reload it into another context and then continue from there. Right? So that's what makes it very interesting, right? So if I take my memory and I save my memory and you add your memory to it, then now it becomes more interesting. So what has happened is that if you go to something like Hugging Face, okay, Hugging Face has lots of models which are available. Now इसमें भी एक ओपन का फंडा है कि ओपन मतलब क्या, ओपन वेट्स, ओपन ये सब 3-4 तरह के ओपन है. बट इसका ये है कि आपको इसको ट्रेन कैसे किया है, इसका एल्गोरिथम नहीं मिलेगा, बट हमारा ट्रेन मॉडल आपको चाहिए तो आप वेट्स रख लो, इसका एल्गोरिथम कॉमन है, हम लोग इसको फिर से लोड करके वहाँ से आगे चल सकते हैं. तो इस तरह के बहुत सारे ऑप्शंस हैं. अगर हगिंग फेस में जाओगे तो वहाँ पे पूरा कैटलॉग है इस तरह के मॉडल्स का. तो अगर आपको कुछ करना है तो आप वहाँ से यू कैन स्टार्ट विद अ मॉडल फ्रॉम देयर एंड बिल्ड ऑफ दैट. So one of the other interesting things to note is DeepSeek, for example. DeepSeek was this big Chinese model. So what did they do? They found that these 700 billion may be too many parameters, and a lot of these matrices that get generated are quite sparse. They are using 32 bits for every particular point. So all of these kinds of things. So they didn't have that many GPUs, and they were not trying to go in the maximalistic way. So they decided to prune it, decided to go simpler, create a smaller, simpler model, and open source it, and that also was quite good actually. So even with fewer parameters, lower budget, they were able to build these models and made it open source. So a lot of people today, when they are doing, especially when you go to the enterprise or when you build our own things, you take an existing model from the open source catalog, like at Hugging Face, and then you train it for your own things, or you build it on your own stuff. हाँ, वो होना शुरू हो गया. So अभी इसका कारण क्या है देखिए. See, the reality is in the foundational model, the training set for foundational model is based on the common crawl and plus.
The
right?
world over. Yeah.
World over. But it doesn't necessarily have it has its own thing, it's got its own biases, but it doesn't have my data in it necessarily.
Your data is private data.
Yeah, मेरा data private है. So I'm running a, let's say, a hospital, and I have my hospital data. My hospital data is not making it into the thing. Neither do I want to make it there, because if I put my data in there, then पूरा privacy सब मेरा जो सब पूरा निकल जाएगा. मेरा जो भी उसमें secret sauce है या information है जो patients के बारे में है, that will now become available to everyone. So that's a problem, right? So I don't want that to happen. So what do I do, right? So this is sort of where there are many techniques that people use for kind of managing this thing in a very specific environment. Let's start 2-3 simple things. So first is अगर हम लोग, so why do we need to have sovereign models? So let's start with that, right? So
and that's something very big.
India is trying to do sovereign models and all that. इसका कारण यह है कि if जो हमारा data है, it doesn't have adequate representation in the global crawls. So we need to make sure that our data, which is जो हमारा local है, हमारी languages हैं, हमारा जो video है, हम लोग जिस तरह से बात करते हैं, जो भी है, that needs to go into the crawl and that needs to be prioritized. हमारे biases, हमारा history, ये वो. अगर हम लोग हमारा नहीं डालेंगे, तो what will happen is that our children, they will never know anything about our history, right? Because nobody has trained the thing. हम लोग पूरा हिस्ट्री तो अभी ChatGPT से पढ़ने वाले हैं, तो अगर हमारा है नहीं तो कैसे होगा? So इसलिए we have to have our own sovereign models, and that's why people are doing that.
Is there another motive to sovereign model, like energy related, or it is largely?
Well, it can be, but this is the main reason कि हमारा डेटा हमारा है, तो हमारा डेटा का हमारा मॉडल होना चाहिए. And of course the other related thing is कि we of course should know how to build models, and we should have the capability to build our own models. And of course there's also the risk कि कल को कुछ हो गया और अमेरिका चाइना का हमारा नहीं बना दे जैसे कि नहीं हम लोग आपको यूज़ नहीं करेंगे, हम जियोपॉलिटिक्स से काट दिया, कुछ और हो गया, भाव बढ़ा दिया, तो हमारा कंट्रोल हमारे पास होना चाहिए. इसलिए सॉवरेन मॉडल्स बहुत इंपॉर्टेंट है.